Welcome to this interview on the Internet, artificial intelligence, and Christian faith. My name is Alexander Fink, and I lead the Institute for Faith and Science in Germany, and I'm the co-director of the Science Network of the European Leadership Forum. And today, I will have a conversation with Charlie Catlett, actually, from Chicago, and he has been involved in the development of the Internet, and he has had several leadership positions in national laboratories and in universities, being involved in cybersecurity, internet, artificial intelligence, and so on. So I'm sure we have a very interesting conversation with a real expert here. Welcome, Charlie.
Thank you, Alexander.
Charlie, you have had a long career in computer science and in the internet, about 40 years, if I guess right. Could you give us a big picture overview of the creation and development of the internet and artificial intelligence during the last 40 or 50 years? What would be 5 milestones, so to say, on that road?
Yeah, sure. I think obviously from my own perspective as somebody involved in those particular aspects of technology, I would view a few of these I would say, inflection points in technology that I think have been important, and maybe even thinking of how they have gotten us where we are today with artificial intelligence. And so I'd say the first two were things that happened before my career began in the 60s and 70s, which was the development of microprocessors, the ability to take a processing unit for a computer and shrink it down, and then further shrink it on a computer chip. And during the late 60s and early 70s, also the development of the technologies that underpin the internet, the technical protocols for how you format data and how it's moved around and how it makes its way from point A to point B. And those were developed primarily by scientists in the UK and in the US. And a big part of that was a network called the ARPANET, named after the Advanced Research Projects Agency in the US. And that connected many military organizations or sites, as well as a small number of universities that were involved at the time. Like you can count it and name them all, not small as in hundreds, but small, really small. So those are two technologies, microprocessors and internet technologies, that I would say in my career as it began, I inherited. What drew me to most of my work in the last 40 years was, first of all, a fascination for how to build computers, how to architect computers. And I saw a picture in about 1985 of a supercomputer which looked science fiction. It was just this intriguing shaped machine, looked like something off the Star Trek Enterprise. And I said, that looks really interesting. And from there, I got into what I'd say is one of the a third of these big things, which is high performance computing, or sometimes we say supercomputing. And that is what allowed us to begin to apply computation not just to business problems, but to scientific problems, and to do computational simulations or models of scientific phenomena, whether that would be the design of an aircraft wing or an understanding of how storms form. So high performance computing would be, I'd think, number three. The next would be the growth of the internet, which began in about the 1980s, and I was involved in helping to create the backbone core of that as it grew out to universities. And
what's the backbone core?
So backbone core, sorry. So in the United States anyway, where this activity began, we connected 5 supercomputer centers across the country with high-speed telecommunications lines. We wouldn't call them high-speed today, but they were high-speed at the time. And then from each of those 5 points, kind of forming a backbone, campuses connected to one of those, and the internet grew out from that central core network. And so my role was in that central core network and trying to figure out how do we scale the network beyond 5 to 50 to 500 to 5,000, 5 million, et cetera.
More and more users.
More and more users. And more and more users really came with, I would say, the next inflection point, which was the World Wide Web. This is based on.
When was that, the World Wide
So,
Web?
so the World Wide Web was in the late 80s, 89 or 90, maybe 88. Tim Berners-Lee at the European Physics Center, CERN, outside of Geneva, is the one that encoded the first software that would allow you to put a document on this computer that's on the network and have a link to a document on another computer on the other side of the network, to link these documents together. And that's a concept that came from a 1945 paper by a person named Vannevar Bush, who was an advisor to the President of the United States and helped to start the National Science Foundation.
1945, which
1945,
was
yeah, he wrote
40 years before.
Yeah, he wrote a paper talking about the memex, and his concept was that you would have this desk in a window on this side of the desk that would look down, what we would say it's a computer screen, into a database of all the world's knowledge together, and that the information would be linked together. So if you're interested in this topic, just like you see on the web today, you can click and find out more about that thing that is referenced. So the web really was, I would say, another milestone. And my role there was, I was at the National Center for Supercomputing Applications in the University of Illinois. And one of the groups that reported to me was responsible for the servers that we released a browser called Mosaic, which is the ancestor of things like Chrome and Internet Explorer, et cetera.
And Netscape and so on.
Netscape actually came out of the group. That company was formed from that group. Mm-hmm. And so as these browsers were downloaded, it was a free software, and hundreds of thousands of people were downloading. And whenever that software...
I was one of them, yeah.
Yeah, I was one of them too. But when you start up that program, it would give you a page, your starting point for the internet. And that page was stored on our servers. And so as 100, 1,000, 100,000 browsers started going out, these servers, we had to really figure out how to grow the capacity of those servers and make them more efficient at fielding all of these requests. So there was some interesting computer science work there. So is that 4 milestones?
It has been 5 already, I think.
It has been 5. Okay, so then I'll say there's one more, and that is something called deep learning. And this is where we come with artificial intelligence. The dominant way that artificial intelligence is done today, and for the last 20 or so years, uses artificial neural networks. And by that I mean a computer program that within it has programs that are neurons, and those neurons connect with other neurons within that computer program. And that's called a model. And so we think about an artificial neural network. We talk about the scale of a network, and we talk about training a network. And as these artificial neural networks grew in complexity and size, what we found was that initially we called it machine learning, which was a very simple approach, which if you've used a CAPTCHA on a website, it tells you click on the boxes that have dogs or fire hydrants or whatever. And machine learning required all of the data to be labeled so that you would send pictures as input to your program, your neural network, and it would have an output, and if it was correct that this picture has got a dog in it, then you note that, or the computer notes that, and over time it adjusts all of its connections so that it more often than not gets the answer right.
The right dog, cat, and so on.
Exactly, exactly. And so when we talk about neural networks, these neurons are interconnected, just as ours are, and we have 100 trillion connections between our neurons in our brain. The kind of models that were machine learning models might have 1 million connections, and they were good for doing certain things like character recognition or the like.
And today we are with JetGBT at how many neurons?
Well, so ChatGPT came out in November, and it had 175 billion connections between neurons. And GPT-4 that came out in February or March a follow-on to the one used for ChatGPT, has 1 trillion connections, so 6 times larger than the one. And the one before the release of ChatGPT only had about 1.5 billion. We call them weights or parameters. But that's essentially the representation of those connections. So
that's quite a lot. But our brain still has more connections. Yeah.
We still are 100 times more in terms of number of connections in our brain. I was going to say more complex, but I'll just say larger, because we don't yet know the complexity of the brain. But these models that we're using are not so complex.
Yeah. We know exactly how a computer is wired in its neurons, but we don't know about the brain exactly how it is wired. Yeah.
Yeah, or what the different parts of the brain do. But in a neural network, we know exactly what each of the neurons is doing because we programmed them to do that. And so people talk about machine learning and deep learning. And deep learning is, I would say, that was probably my 6th or final inflection point, was deep learning. That just means a very complex and very large network of neurons with their interconnections. And that gave us much better performance on things like image classification. And then as we began to build neural networks out of neural networks, so a hierarchical complex, we got to where we are today, still with deep learning, where we have these very complicated constructs, one called the transformer, which sounds cool because of the movie, but the transformer. And it's based on that architecture, that complex neural network, that we have large language models like used by ChatGPT.
And that's exactly the word that is the buzzword at the moment, ChatGPT. A lot of frantic news headlines were written in the last 6 months about ChatGPT, I would say. So, what do you think about ChatGPT? What's so special about it? And why do you think that Geoff Hinton, called the godfather of AI, why did he have a private conversation with the Google CEO? And why did he step back? What's the problem with that?
Well, I don't know either of them. Haven't met them, so I can only go with what he said and have watched his lectures. But I think I would just say, as he did, he felt that, so he was concerned about the progress that this technology had made in terms of exhibiting capabilities that it wasn't programmed to do, that appear to be more advanced than just a language prediction model, which is all it was originally.
So what could it do? What was not expected?
Well, I think one of the things that Geoffrey Hinton talks about is that he was interacting with this ChatGPT, or the model behind it, and he told it a kind of an inside joke and asked it to explain why that joke was funny, and it was able to explain why that joke was funny, even though it wouldn't have been part of any of its training data, any of the data that was used to build the model. And other people have done experiments that point to the possibility of reasoning in addition to just predicting the next word, which is originally what these models were intended to do. It's very difficult in the same sense that it's difficult for us to, when we think about what's the difference cognitively between a human and a primate, how do you do those tests? And so people are doing tests through a language interface and trying to figure out, is there some theory, the theory of mind? Can ChatGPT think about what another person is thinking about? Which, when you say it like that, it seems absurd because it's just a mathematical model.
So how does that mathematical model work, and why would it not be expected that it could think reasonably like we do?
It's a technology that really started as a word prediction technology. And so when you're typing your mail and your mail program predicts what your next word is, that's really the technology this is built on. Obviously more complicated and much larger, but we were beginning to be surprised by these language models, I would say, starting about 2 years ago. The fact that they could not just do a word prediction, but actually create an entire paragraph or an entire page. And in the intervening 2 years, I'll call it creative skills of these large language models are quite surprising. in that what's happening is I'm saying, write a story about Alexander and Charlie in Dr. Seuss style, and write me a 12-page cartoon story about the interview.
And would everything about us be true?
And so that's a very good question. So it's surprising that it would write that story, because that's predicting not just the next word, but it's somehow predicting what you intended with what you told it. And this, you bring up a really significant challenge with artificial intelligence and with these models, in that in the process of predicting that next word, it will fabricate information that's not true, and even reference papers that never were written. And there's no intention, it's a mathematical model, but this we call hallucinations is one of the challenges technically to AI that came to really manifested itself with the ChatGPT.
So let's assume that a high school student, uses ChatGPT in order to write their essay. And let's assume that ChatGPT came up with a text that has no errors, no content errors. Would the teacher be able to find out whether this is an AI text? Are there programs like Zero GPT or something like that? I've heard about that, which can find out whether there are AI-generated texts.
There has been research for a number of years now to try to develop algorithms and techniques to spot the AI, to spot differences. And they started because of things like bots creating things on the internet, and fake product reviews on websites. And so the work started by saying, okay, here are 1,000 product reviews, which ones are human generated and which ones are AI generated. That technology has some catching up to do with GPT-4. I think in some cases it would be evident to the teacher, but I think if the student is clever, then they probably could certainly pass off an essay from this.
So the student only needs to make sure that ChatGPT did not make up or fabricate any information that is not true, and as long as the student takes care of that, he might have a perfect essay.
Right, and the thing is that if the student's really clever, and I think this is at this point, I think people really need to think about these as a new kind of computer that gets programmed, and so this is one of the remarkable powers that the language model says is, if a student is clever, he or she could say, I want to write an essay on rose gardening, and I want that essay to be on in the voice of a high school student. And in fact, that student could take their previous writing and push it into the model as part of their prompt and say, here are my 4 essays I've done so far. Write another essay about rose gardening using the same style as those other essays. Wow. So that's the kind of surprising power that these models have. And that gives us some hope, I think, as believers, that this could be a technology that could help us in the gospel. Mm-hmm. The translation power, for example, of these models. And Facebook just this week announced a language model that can do 1,000 languages with very little training data. Mm-hmm. To start with, because some languages have very little data. So, of course, you want a human, you want a believer to check the translation of the Bible, but boy, it could certainly speed up the process.
Obviously, like any technology, this brings with it a lot of opportunities, but also, of course, dangers like wrong information, fabricated information, and this could multiply, of course, because everyone has access to these tools, and they could be used even in social media and so on. So if you had the chance to talk to policymakers just for 3 minutes, like an elevator pitch or something like that, what would your advice as a computer and cybersecurity expert be to them? How should we go about regulating these things? Because some countries like Italy, they have shut down ChatGPT completely, at least as of the summer 2023. And China has as well. Other countries allow it to be used completely free. What would your advice be? How should we deal with that politically?
Well, let me separate regulation from safety and guidelines, and leave enforcement or that as a kind of a separate issue. I think there are some things that need to be done, and these can be done without a regulation by companies and governments having an honest conversation that's more than just a hearing or a summit in a, where a photo gets taken. So one of those is that the data that's used to train these models is what determines many things about the model, including any sort of biases the model might have. And those biases are picked up by the data itself. The internet, if you think about, let's train a model with the entire internet, the internet content that we have today has been mostly generated by Europe and the US. And that content, just because of the history of the internet, and it's been around the US and Europe much longer than other parts of the world. But even within that content, many of the source sites that you might use to train a model are dominated by white men between the ages of 18 and 34. So the data makes such a huge impact on the way the model performs. And this is also the way that a company or a nation state would be able to use a model to influence their population by training that model with the biases that they want to build into their society.
Also certain worldviews, for example, that some worldviews are overrepresented and others are underrepresented or viewed as being false, maybe, yeah?
Yeah, and cultures that are not represented on the internet are not going to be part of the model. So there's some, I think, trepidation regarding the models and misinformation and bias as part of that. So back to the notion of what we might put up as guardrails. I think data provenance, which means we need to know what data was used to train the model.
So transparency.
Transparency. Yeah. I think also it's important to begin to realize that these models are being trained by data that is obviously it's public data, but it was put into the public onto the internet for people to individually view, and there was never any discussion about using that data, the work of an artist or performer. There was no discussion with them about using their data to train a model that can now compete with them. And so this gets us to, I think, another need, which is to recognize that there's some responsibility in building these large language models to appropriately work with the creators of the source data. And as these things are created, it's important for us to know whether a piece of art or a movie or a picture or an essay was developed by a human or an AI. So the notion of labeling AI. So yeah. I tend to think that there are a couple of areas where we've seen success in safety, if you will, that are worth considering for AI. So one is the regulation that we have around anything you plug into a wall outlet that runs on electricity. Mm-hmm. And we all have a vested interest in not getting electrocuted, and so you can't sell a device that plugs into the wall unless it's been verified and tested for safety. So we should think about what are the verifications and testing that we would consider if we were going to say this model is safe. What do we mean by safe? And so until we have the answer to that, regulation is who knows what to rate it. The other model I think that is worth considering is the biological safety model, where in some uses of AI, let's say to control a laboratory, you need to take certain precautions to ensure that that technology doesn't fall into the wrong hands, if you will. And so the biosafety levels, the notion that I have to have a certification of my laboratory to work on certain things. I'm not suggesting that in order to work on AI, you have to get a license or anything like that, but I think that kind of concept is worth thinking about.
So we first need to define where we want to go to and what we want to have, and then we need to design the technology in a way that it arrives there. Among Christians, I think there are many different opinions. I mean, I see especially two ends of the spectrum. One end would be very positive and say that ChatGPT and AI is actually the new letterpress, It's a new revolution of information, and everyone has free access to information and can share information at the same time. And so you mentioned an opportunity to translate the gospel into many other languages without having to learn these languages and so on, which might be much faster than before. And we see it happening, that these things get real, actually. On the other hand, we have the other side, that people say AI is just a bridgehead into the book of Revelation, of a totalitarian supervision system where only a few people with certain devices can actually partake in trade and in social life. And we also see that happening when we, for example, look to China in the moment. So what is your perspective as a Christian? Should we be afraid? Should we be unconcerned about that? Probably somewhere in the middle. What is your perspective on that?
I think, with any new technology, there are legitimate reasons to be cautious and to be hopeful. And for me, it helps me to think about the dangers or concerns regarding AI in three categories. So the first is the technology itself. How can we build the technology so that it doesn't give wrong answers? How can we build the technology so that we know when we get something from it, it's not a hallucination? So that's the technology itself. The second bucket is using the underlying foundations of artificial intelligence to build an artificial intelligence capability, like a large language model. And there, it's important for us to think about the bias of the data, to think about other capabilities that we might concern ourselves with, such as if we are controlling a laboratory to make a drug, that same mechanism could be used to make a bad drug as much as a good drug. And then the third category, which is where I think we need to spend, many Christians are not computer scientists, so the first category is kind of out of their ability to influence. The second category, more people, Christians, are involved in building these things, and so they can bring their values to the training data, for example, and in the values of making sure that people aren't overlooked, especially that disadvantaged people are well represented. Then the third area is the application of those AI products and creations in society, the application of AI in a social network, the application of AI as a news feed or as a research tool. And in that third area, I think we can both influence the way that goes, no matter who we are, but we also have control over how we use the technology. And I think that one of the things that's happened in the last 10 years is that we have not heeded the advice that we used to say 20 years ago, which is don't believe everything you read on the internet. And I think people have been lazy about that. And the reason is that the internet is language, and language is powerful, and gossip is powerful, as we know from Proverbs.
Social media,
yeah. So social media. So I think it means that we need to be very vigilant about the information that we're getting, and be diligent about looking for what's the source of this, what's the motivation of that source. And I think the red flag that we need to just be sensitive to is, if something is causing me to be outraged or upset, then I'm being manipulated. Mm-hmm. And so I want to know, why is the source wanting to manipulate me? And I want to sort of take a step back. But it's so easy, because language is so powerful, to just kind of go with the outrageous thing that makes us, upset.
Yeah, thank you. I think this is a very wise statement. So only who is involved with it and works with it can also help to make decisions and also contributes data. So we need Christians who are involved in that development, obviously, as you are. Would you say that in your career there have been some moments where your Christian faith made a difference somehow?
Well, I think there probably have been moments. I think that my Christian faith and respect for people that comes from that faith has influenced the way that, in my own work, that we've approached the use of AI in street furniture, in using cameras and AI with the cameras to measure traffic flow or what have you. And to develop a way to do that that respects privacy and then goes one step beyond that and says, as we've put up a number of devices in Chicago to monitor everything from rainfall to traffic flow, to make sure that the people who live in that area of the city that we're putting our device at, to make sure they're okay with us doing that. So my valuing people because of the gospel has caused me to approach this kind of work with a respect for people and a feeling of responsibility to explain what we're doing to them and make sure they're with them or make sure they're okay with it. And then the other one is just general, is that I don't remember who said this, but I, as I was a young manager, I read this quote that said, the only way that you can lead people is if they are convinced that you care about them. And the only way to convince them that you care about them is to actually care about them.
Yeah.
And so I felt like every person that God puts in my life, I want to, and I'm not saying I'm successful at this all the time, but I want to exhibit a hope that causes them to cock their head and possibly say, where is that hope coming from? And at that point, I have an opportunity to explain the hope that's within me, as Peter writes in 1 Peter.
Yeah. Thank you. Yeah, and I think this is a way how we can even look at the internet. God is in control. We don't know what will happen in the future in history with the internet and with the artificial intelligence and so on. But God is in control and he knows, and we can just be faithful to him. So thank you, Charlie, for this hopeful interview, which hopefully gave you some helpful insights how to think about artificial intelligence, ChatGPT, and so on. And just as a disclaimer, this interview has been done with real people. I'm Alexander, this is Charlie. It's not produced by artificial intelligence. Thank you, and God bless you.